Hello students, welcome to Educate. Today we are going to start next chapter of class 12 physics. The chapter is moving charges and magnetism. So there was an experiment conducted by Christian Ørsted, and this proved that moving charges produce magnetic field. You have studied about it in 10th level also. Now we are going to see what is the force on a charge that moves in combined effect of electric field and magnetic field. So here we write force equal to QE if charge moves in electric field. If there is magnetic field also, in that case force will be V cross B, where B is magnetic field and V is velocity of the charge. Now here we are using the term magnetic field. So about magnetic field we must know something. So magnetic field is represented by B. It is a vector quantity and its units, if we consider SI, it is Tesla, and if we consider CGS, so it is Gauss. Now if we see the relation between the two, 1 Tesla is 10 power 4 Gauss, or 1 Gauss is equal to 10 power minus 4 Tesla. Now one more thing that is important is the direction of magnetic field, and before considering that, let's see how it is represented. So if magnetic field is perpendicular upward, then we put like this circle with the dot, and if field is perpendicular down, then we put cross inside the circle. So these are basic concepts that we will make use. Now starting with force, so F equals QE plus Q times V cross B. This force is called Lorentz force. Here, if electric field is absent, in that case, F will be equal to QV cross B. Now, V cross B being a vector, so here V cross B will be another vector whose direction will be perpendicular to both V and V. So direction of F, if you want to determine, then you have to use the concept of cross product. Thereby you will get the direction of F. For example, suppose V is 2I cap. It means particle is moving along x-axis, and B is suppose 4K cap, means magnetic field is in the perpendicular upward along z-axis, and you want to find out the direction of the force. In that case you can say F will be 2 into 4 and then I cross K. And if you remember the rule, if you write here I, J and K and you move in order, then cross product of any two will give the next one. So here you are moving in order or opposite. I cross K, you are moving I cross K just opposite. So it will give minus J. So it will become minus 8J. So along y-axis, but in towards negative y-axis. So this is how we can determine. Now suppose we want to find out its strength. So F will be QVB sine theta. If theta is 0 degree, in that case force will be 0. What does this mean? It means if charge particle is moving in the direction of magnetic field, then there won't be any force. But if theta becomes 90 degree, in that case what happens? F will become maximum, because sine 90 degree is 1. So this is basic point. Even theta is 180 degree, in that case also force will be 0 because sine 180 is 0. Now we are going to see magnetic force on a current carrying conductor. So F equal to BIL. This is basic relation that we are going to see here. So let's read it and then I will analyze. We can extend the analysis for force due to magnetic field on a single moving charge to a straight rod carrying current. Consider a rod of uniform cross-sectional area A and length L. Area is A, length L. We shall assume one kind of mobile carriers as in a conductor, here electrons. Let the number density of these mobile charge carriers in it be N. We have already studied number charge density. Then the total number of mobile charge carriers will be, here N is number of electrons per unit volume, and we are taking area as A, length as L. So volume will be A into L, and here number density is N. So total number of electrons we can say as NLA. Now for a steady current I in this conducting rod, we may assume that each mobile carrier has an average drift velocity Vd. So in the presence of an external magnetic field B, the force on these carriers will be, from which concept? Recently you have studied F equal to QVB. So V is to be taken as drift velocity, B is to be taken as magnetic field, F here. Total charge as we have seen here. So here the total number of mobile charges this much and charge is say Q. So just to multiply to the number, so you will get this number NLAQ times VD into B. Now if you introduce here current density, you remember J is current density, J is I upon A. So here now NQVD is the current density. Why? Because I equal to NEAVD, right? So if you divide this I by A, I upon A equal to NEVD. So you have got J equal to NE, here E is written as Q and A is the current. Then this is NEVD A and then is the current, divide by A, it's written, keep in mind. So then from here it is clear, I upon A equal to NEVD. Then what we can write? So it will become J into AL in this formula. So J, A leaving AL, so NQVD will become J. So here we have got JALB, and then this can be further written as J into A, again it is I, so ILB. So where L is vector of magnitude L, the length of the rod and with a direction identical to the current. Note that the current I is not a vector. In the last step, we have transferred the vector sign from J to L. So that is clear. So you have got the relation F equal to BIL in terms of vector if you write, so it will become F equal to BIL sine theta. Here, suppose this is direction of magnetic field and suppose current carrying conductor, this is I, conductor carrying current I, this angle is theta. So in that case, force on conductor can be found, and force will be maximum when theta will be 90 degree, because in that case force will be BIL in magnitude. And if conductor becomes parallel to the magnetic field, in that case there will not be any force. So this is simple concept. Now here there is one question in which force on conductor and its weight is to be balanced. So question is simple. If you read it, what do you observe? A straight wire of mass 200 gram and length 1.5 meter carries a current of 2 ampere. It is suspended in mid-air by uniform horizontal magnetic field B. What is the magnitude of the magnetic field? So it is very simple. If it is suspended in air, so F due to its weight and F due to charge movement, so QVB, but here BIL is to be applied. So BIL, both should be equal. So you can equate mg equal to BIL, from where you can get B equal to mg upon IL. So you can put the values. So M is given 0.2 kg, 200 gram, G is 9.8, and I current is given as 2 ampere, and length of the conductor is given 1.5. So you will get the answer as 0.65 Tesla. Here, there is another question. The question says, if the magnetic field is parallel to the positive y-axis, if magnetic field is parallel to the positive y-axis, so you can say B, if you write in terms of vector, so you can write B vector is B times j cap, and the charged particle is moving along the positive x-axis, and the velocity vector is, you can say, V times I cap. Now, which way would the Lorentz force be for an electron, for a proton? So here, if you want to find out force, so F will be QV cross B, right? And here you have to find out direction of F. If here, if you put, just keep it Q, later on for electron you will write here minus E, and for proton you will write plus E. So you can easily get V is, we can write V times VB together, and then I cap cross J cap. So here this cross product is in order, right? Because if you write here I, J, K, so you will get next one. So here I cross J, so it means you are going to get K cap. So Q, V, B, K cap. This is direction of force. Now, if this K cap means positive z-axis, so if charge, this Q is replaced by electronic charge minus E, V, B, K cap, then here force will be perpendicular downward, means it will be along x-axis but in negative direction. And if we take proton, so the same charge will be replaced by plus E, V, B, K cap. So force will be perpendicular upward. The same thing is written here. If you read it, so now we are going to see next aspect. So next thing is motion in a magnetic field. If there is a charged particle and it moves in magnetic field, and the field is perpendicular to its direction, in that case there will be a force called centripetal force, mv square upon r will act, which will take the charged particle in circular path. But if there is acute angle, in that case the charged particle will follow helical path. So we will see both the situations. So let's see. Here particle, magnetic field is perpendicular down, and particle enters like this. So it will follow, you can say theta will be 90 degree. So particle will follow circular path, and if it is following circular path, it means there is centripetal force. So this force QVB, as we have seen, QVB, theta is 90, QVB is sin theta, so theta is 90. So that is one, is providing centripetal force. So if it is providing centripetal force, so we can find the radius of the path, means whatever circular path it is following. So R will be equal to mv square divided by qvv. So one we will consider out. So mv upon qb. So a radius of the path followed by charged particle can be easily evaluated. Suppose we want to find out time period or frequency. So time period is length, this 2 pi r divided by velocity, right? So 2 pi r is this 2 pi r is mv divided by qb and divided by v. So we will cancel out and you will be left with 2 pi m divided by qb. This is time period. And suppose you want to find out frequency. So frequency will be 1 upon time period. So just reverse it, qb divided by 2 pi m. So you can get two values. Now if we consider it's a kinetic energy, so velocity we can get from this relation. Suppose we need kinetic energy. What we have evaluated up to here, we have evaluated that qvb equal to mv square upon r, and we need kinetic energy. So either we can write 1 by 2 mv square, from here we can get, or just write the relation between this mv square divided by qvb, and then what is kinetic energy? Half mv square. Write the relation for velocity and then you can write. So anyway you can get, we will see in next question. So as you have seen that when particle enters at 90 degree, then it follows circular path and we can get radius, velocity, kinetic energy, etc. And suppose particle enters at certain angle, say angle is theta. Here, in that case, particle will follow this type of trajectory, and this is helix, we can say helical path. In such case, here velocity will have two components. This is velocity, so this will be v sine theta. So v sine theta, so here if we find mv square upon r, in that case it will be qvb sine theta, qvb sine theta. But keep in mind this velocity term will be, since this velocity is to be considered, here also you have to write v sine theta, then you will simplify. So that we are going to do in next step, but here detail is not given, so let's analyze it so that we can find the various parameters. So as I told you, particle will follow this type of trajectory, and here this distance is called pitch. This velocity v, this angle is theta, so v sine theta will be responsible for circular path, from where we can find like mv sine theta whole square divided by r is equal to qv sine theta into b, qvb sine theta, and then we can get the value of r, we can get the value of velocity. And now if we consider its horizontal component, so horizontal component will be what? V cos theta. So due to V cos theta, particle will move in this direction, and suppose it takes a time t in one complete revolution, then pitch can be found as, say, pitch p is pitch, so pitch equal to time period times V cos theta. So we can also say this is perpendicular component, so V perpendicular, and this V parallel we can denote. So that is also one possibility. The same thing is written here. So let's do one numerical based on it. So here there is one numerical in which every information is given. What is the radius of the path of an electron? Mass is given, charge is given, moving at a speed of 3 into 10 power 7 meter per second in a magnetic field of 6 into 10 power minus 4 Tesla. perpendicular to it, what is its frequency, calculate its energy in kilo electron volt, whereas where 1 kilo electron volt is 1.6 into the power minus 19 joule. So let's evaluate it. So here we have already derived the relation for radius, that is mv upon qb. We can put the values. Mass of electron is given 9 into 10 power minus 31 and the velocity is given 3 into 10 power 7 whole divided by q. Charge on electron is 1.6 into 10 power minus 19 coulomb and the magnetic field strength is given as 6 into 10 power minus 4 Tesla. We evaluate it, so radius comes out to be, this comes out to be 28 centimeter. So this is one thing we have evaluated. Now frequency. So frequency nu can be found by velocity divided by path length, that is 2 pi r. So we can evaluate by putting the values. Velocity is given, radius of the path we have just evaluated. So after putting the values, we will get it as 17 into 10 to the power 6 hertz. And 10 power 6 hertz is million hertz or megahertz. So we can also write 17 megahertz. So this is one thing. Now, if you want to find out kinetic energy, so kinetic energy is half mv square. So in our question, mass of electron is given, velocity is also given as 3 into 10 power 7. So just put the values. So 1 by 2, mass of electron 9.1 into 10 to the power minus 31 into velocity 3 into 10 to the power 7 whole square. So if you evaluate it, it will come out to be 40.5 into 10 power minus 17 joule. So we get energy as 40.5 into 10 to the power minus 17 joule. And we have to convert it into kilo electron volt. So we can divide it by kilo electron. Kilo means 1000 and electron volt means electronic charge. We write here 1.6 into 10 power minus 19. And then we can simplify. So we will get around 2.5 kilo electron volt. So this is answer. I think you have understood it fully. We will continue next concept like magnetic field due to a current element, Biot-Savart's law, and after that we will see this application of Biot-Savart law, then magnetic field on the axis of a circular current loop. By using Biot-Savart law we can evaluate. Then Ampere-Circuital law we will study. After that there will be one very important question based on Ampere-Circuital law. This is frequently asked in exam, and graph for that. And then there will be expression for force between two conductors. This is magnetic field due to solenoid, and 3-4 things are there that we have to study, and then chapter will be over. A lot of things are removed from CBSE syllabus. So I think you have enjoyed. Thank you for watching. Team Educate.